My name is Terje Arven, and I'm Professor of Risk Assessment and Risk Management at the University of Stavanger, Norway. I often ask people working with risk, what is your field, your science and discipline? I hope they say something about risk, but what I say is, I'm a sociologist, I'm a statistician, an engineer, economist. I myself has a background in probability and statistics, but my field is risk. This is important for me. We have professorships in this area. We have master programs, PhD programs, scientific journals and conferences. It's actually a well-defined area. But not so many people know what this area is all about. The risk field is broadly and simply about two main categories of activities. A. Studies and management of specific activities, like the operation of an offshore installation or a financial investment. B. Generic, general risk practices and research. How to conceptualize, understand, assess, characterize, communicate, manage risk. The B part influences the A part, but we also have the other way around, that the A part influences the B part, as we will see later. This is an offshore installation where oil and gas is produced. There is risk associated with this activity. Fire and explosion may occur, leading to loss of lives and oil spill and environmental damage. We may question, is the risk too high? Should we reduce the risk? And how much? And in what possible way can we reduce the risk? These are questions that are not straightforward to answer. And to answer them, we need competence in risk assessment and risk management. But we also need other type of experts, like process engineers and people with experience, operational experience, to be able to answer these questions. Now, how should we carry out these studies and this management of risk? The risk field has developed some recommended practices for how to do these studies and this management. And these are subject to continuous scrutiny to be able to improve and develop these studies and this management. And this is what the generic general part B is about. For example, when asking about the offshore installation having too high risk, what do we mean by that? Too high. How do we decide what is too high risk? These are complicated questions, and to answer them, we need competence in risk assessment and risk management. The B part covers a set of activities. It could be all offshore installations, or a broader set of activities, like technical systems of a certain type. And it could be even further than that, even broader than that, covering all types of activities: engineering, medicine and health, finance and business, climate change, security, transportation, and so forth. For all these areas, we face risk. We need to address risk. We need to assess risk, manage risk. And the question is how to do that in the best possible way. Of course, all areas need tailor-made methods and procedures. But there is something generic that applies to all areas. Going back to the question about what is risk. If we're going to manage risk, we need to understand what we're going to manage. And it doesn't make sense to have one definition and one understanding for each application when we're facing the same type of question. About 300 years ago, the French mathematician Abraham de Moivre, said that risk should be understood as expected loss, meaning probability times loss, summing over all possible loss values. This way of understanding risk is common also today. People would like risk managers, decision makers, to be guided by this way of thinking, expected loss. However, most risk researchers today would argue that this way of describing risk, understanding risk, is unfortunate. Decision makers could be seriously misguided following this principle. The problem is this: if you follow this idea, you will not reflect in sufficient degree the possibilities, the tendencies, the likelihoods of having extreme outcomes. And this leads to our second suggestion for how to understand, define risk. Risk is considered to be the combination of consequences of the activity with some scale of magnitude or severity and probability. This way of understanding risk has been perhaps the most common way the last 30-40 years, at least in the engineering environment. And here is one example of a risk description in line with these ideas, where the consequences are with respect to the number of fatalities. 1, 2 fatalities, 3, 5, etc. This is another example, a standard risk matrix, showing the two dimensions, consequences and probability. Now, this way of understanding risk with consequences and probability is obviously more informative than to multiply them together, giving the expected value. But also care has to be shown when you have this way of understanding risk with both dimensions. This is what the generic Risk Research B is telling us. Let me give an example from my own experience and research, showing the need for seeing beyond this perspective on risk. It also demonstrates that a concrete study can influence the generic risk research part B. Many years ago, I worked in an oil company. Together with some colleagues, I conducted a risk assessment of an offshore installation. The risk was presented in this way, using consequences and probability. And we concluded that the risk was high and measures were required to reduce the risk. This was an example of A, study and management of a specific activity. But it turned out that it also had implications for the generic general research part B. I was challenged by one of the top managers of the company when presenting the results. He was questioning me, "Arvind, what is the meaning of these numbers? And what about uncertainties? Is risk properly reflected by these numbers?" These were good questions, in my view, because the company were going to use a lot of money, partly based on this risk assessment. The problem was me. I could not give a convincing, strong answer to these basic questions. And I said to myself, I have to do something about it. And this created a need for basic research. And the questions that I've been working on since then, how to best describe, how to best understand and describe risk, and how to deal with uncertainties in risk assessment and risk management. The work on a specific risk assessment has led to developments also in B, the generic risk research. And over the years, these developments have resulted in improved practice and influencing the A part, how to do the risk assessment. The risk field acknowledges that this way of being informed about risk is more informative than using expected values with probability times consequences. But also in this case, when you're having both dimensions, you have to be careful. This perspective also has limitations, and improvements can be made. The problem is this: You may have two situations, having the same risk described by probability and consequences, but they are completely different when it comes to the knowledge supporting the probability. In one case, the probability can be strongly supported by the knowledge. In another case, with very poor knowledge. Shouldn't this also reflect the way we describe risk? Yes, it should. A team of experts on offshore operations assign a probability of having a fatal accident due to hydrocarbon leaks to be 1 in 10,000 for a certain period of time. They have strong knowledge, a lot of data, relevant data supporting this. They have good insights, strong insights in the phenomena being studied. At the same time, we have a layperson assigning a probability for the same event, the same number, 1 in 10,000. The situations are very different, but if you look into risk, only through probability and consequences, the risk description is the same. Clearly, this cannot be right. Generic risk research studies such issues, and there is strong support for now to incorporate these knowledge aspects into the way we understand and describe risk. One idea is to replace probability with uncertainty, leading to risk being understood as the combination of consequences and uncertainties. Consequences C, uncertainties U. Going back to the problem I faced in the oil company, I don't say now that risk is expected value or combination of probability and consequences. Rather, I say risk is now the combination of consequences and uncertainties. And to describe risk, we have not only 2 dimensions, but 3. We have consequences, we have probability, and we have knowledge, strength of knowledge supporting these probabilities. An example of these 3 dimensions is shown in this extended risk matrix. Consequences, probabilities, and strength of knowledge judgments. Red for poor knowledge, green for strong knowledge, and yellow for medium. In this case, we have 3 events with 2 green and 1 red. These are insights made by the generic risk research. This also now influences the risk analysis practice in different ways. And some examples are the new glossary from the Society for Risk Analysis, SRA, and the new ISO 31000 definition of risk, as well as the definition of risk used by the Petroleum Safety Authority in Norway, which now defines risk by the consequences of the activity with associated uncertainties. The risk field faces a big generic risk research challenge: how to, in the best possible way, incorporate this knowledge dimension into the way we understand, assess and manage risk. I would like to stress that this is just one example of the many issues that the risk field is addressing. The key point is that we need to see beyond consequences and probability, adding this knowledge dimension. Here are some other examples of issues that the risk field face, the generic risk research part. Does there exist a best way of dealing with risk for individuals, for companies, for society? And how should activities be best regulated in order to balance developments and risk? To summarize, the risk field is mainly about 2 categories of activities. A, studies and management of specific activities. B, generic general risk research and practices. How to conceptualize, understand, assess, communicate, manage risk. We have seen examples of A and B and how they interact. I stress that these are just examples, strongly influenced by my own interest and work. Yet I hope that they have given you some insights into what the risk field is about. The risk field is challenging, but also fascinating. What attracts me is the complexity of the key concepts like risk and probability. And also the fact that we would like to reduce risk, but also increase risk to obtain something. So risk management is basically a balancing act, trying to balance development on the one hand and avoiding disasters, failures, errors and accidents on the other. Think about any activity, an offshore installation or an investment. The driver is really something we would like to achieve, not to avoid failures and disasters. And to make this balance, we need different tools and principles, and the precautionary is one, giving a lot weight to protection. On the other hand, we have cost-benefit analysis addressing expected values, giving little weight to uncertainties and risk. The driver is really on development. Different principles support this balance in different ways. The precautionary principle gives support for protection, as it highlights the uncertainties. Cost-benefit analysis, on the other hand, gives weight to development because it actually gives focus on expected value and not risk and uncertainties. You're welcome to join the risk field with links to A or B. Your contributions are important to strengthen the scientific basis and pillars of this area. It's a young field with a potential for exciting and pioneering scientific work.